Going?
Marcus is very smart. Asked me if I was recording or not.
Oh, so now I got to start over?
I mean, you could start over, but
at least go one slide back.
one slide. All right, hang on a second. First, we got to there we go. Take it away, Jim.
All right, sorry about that. So what we're working on is a bird feeder that adds some intelligence to the feeder and allows you to feed certain species and not feed other species. So the nature of the problem is basically we have invasive species in this country. The most prominent one you probably all know, or maybe don't know about, but should know, is the house sparrow. It was brought over from Europe to actually eat like a moth in New York, and subsequently spread throughout pretty much the entire Western Hemisphere. So this is in the background, there is a map of its range. Its natural habitat is in green, and then its invasive habitat, which is interesting. You probably noticed where Europeans came and thought, hey, let's bring a bird with us. It has had a fairly devastating impact, though, on the native species on top of all the other pressures that it had. The house sparrow is aggressive. It will compete with native songbird species and win. It will kill them. It will destroy nest box, nesting pairs. And basically, the more house sparrows you have in an area, the fewer of these native species you're going to have. And your bird feeder is part of the problem. So what we want to do is build a smart bird feeder that uses a camera to capture a picture of the bird when it lands in the feeder, and then use image recognition, which is now actually gotten pretty good, to identify and classify the bird. And then it'll have rules for whether it should feed or not feed that bird. And then it has just a little servo access controlled feeder mechanism, which will either open and allow them to eat food or remain closed and prevent them from eating food. The goal is to save expensive bird seed. I watched my neighbor's bird feeder. He has 4 of them, and they go through about a gallon of bird seed every day and a half. And then I sit and watch the birds a visit, and it's about 99% house sparrows. And the reality is, they're pretty much all the will ever visit that bird feeder because they are aggressive and none of the other species will visit. So he's basically feeding and making the problem worse. What's interesting, though, is that they're gone for the weekend and the house sparrows drain all the bird feeders. You don't see them anymore. So they quickly learn. In other words, their behavior is easy to modify. If the bird feeders are empty, the house sparrows aren't sitting there looking for food. They go somewhere else. So if the bird feeder denied access to the house sparrows, they quickly learn that I don't get food here, and you just wouldn't see house sparrows at the feeder anymore. And that can be important because if they're hanging out, other species will not be there because the house sparrows will actually drive them away. So what you should see is if you can decrease the house sparrow density on your bird feeder, you should then see an increase in the other species. And that also has potential to reduce the pressure on the native species. If house sparrows are no longer being fed in an area, they have to forage for food. And they do just fine with that, right? I mean, they survived before people came along. Though they have adapted, there's a reason why their Latin name includes the word domesticus, right? They've adapted very well to living around human habitation because that's where the grain was. But they also can forage just fine by themselves. And they would quickly be out looking for food, which also would mean that they wouldn't be guarding the territory as intensively. So that's basically the general idea. So the details are we got a Raspberry Pi with a cheap camera hookup that probably everybody's played with those before. We're running TensorFlow, and Sadiq's going to give us a demo of that hopefully. And then it's a real simple servo control mechanism to open and close a feeding window. So I brought along the first hand around. Put your hands on in over a year. So everyone, please take a second to look at that. It's pretty simple. It's just a little rotary mechanism that either opens or closes the
So
feeder.
this hangs, or?
Yeah, this is just a proof of concept. There's some folks did it's sort of clever, right? It just attaches to any 2-liter bottle type threaded fixture. Reality is it's pretty horrible because the feed doesn't feed well in that shape. This is one that actually does feed well, like another bottle. It could be any kind of bird feeder. This would basically just mount on some kind of feed system. Practically, it has a little auger in there. You probably can't see it. You can unthread it if you want to take a look at the mechanism. It has a little stirrer that also includes the seed production, depending on.
How does it know which bird is which?
It's going to use a camera to take a picture of it, and then it uses it's an AI software program called TensorFlow that looks at a picture And it's been trained, and essentially it's a fairly simple thing, right? It'll say either you're a house sparrow, in which case don't open, or you're some other kind of bird, in which case open. It could be that simple. Now those applications can be trained in great detail. You can download an app for your phone with that you can essentially aim it at anything, and it will do a fairly good job of telling you what it is. If you aim it at a cat, it'll tell you it's a cat. If you aim it at a dog, it'll tell you it's a dog. If you aim it at me, for some reason, it says scuba diver. I'm not sure how it knew that I actually scuba dive, but it do. So no, they're not 100% reliable, and they have issues with the training data set. So our goal will be to capture a bunch of pictures and then train it up with a bunch of photos. I think the application is fairly easy in this circuit because it's just house sparrow or not house sparrow will be the basic decision it has to make. And the other advantage will be typically TensorFlow will give you an identification and a confidence level or how certain it is of what it's identified. And the nice thing is if it's closed, you can, if you're not certain, you can just say stay closed. Because it's not like you're hurting anything by not presenting food to it. So if you inadvertently don't feed a bird occasionally, it's not the end of the world. What your goal would be is to never feed a house sparrow though, so that they would quickly learn that there's not food available at this location and move on. Make sense? Does that answer the...
Are there any negative reinforcement options?
There are some other potential applications we'll talk about briefly. And it could also work very effectively as a don't feed squirrels, which is a huge hassle. Anybody that owns a bird feeder knows that there's squirrels are perpetually your foe when it comes to feeding them versus the birds. So squirrels are smart, they're adaptive, and once they learn that there's food available, they will quickly try to, or spend a lot of their time trying to defeat whatever the mechanism is. And it can make entertaining YouTube videos, but it's also a bit of a hassle. So this would also work as a squirrel mechanism because basically you could present it with a picture of a squirrel and just say, if a squirrel pops up in the frame, don't feed it as well. And again, the squirrels only are attracted to it because at some point they got food from there, right? And typically it's just a case of the birds scattered bird seed on the ground, squirrels ate the bird seed and said, hey, there's more up there, right? You're actually training them with positive reinforcement by having a messy bird feeder as well. And this stays closed until a bird's there, which hopefully would also decrease the likelihood that a squirrel would find it as attractive. Potentially it could also be used for nest boxes because there's, with these house sparrows and starlings, there's also a predation issue, which is they will go into nest boxes of other species. Bluebirds are one, purple martins are another. They'll actually go in and destroy the nest and kill the nesting pair. So potentially you could put this on a nest box as well and just deny them access to a nest box. Because what they're doing is they're competing in their territory to drive away other bird species. And they're very good at it. If you ever watch a purple martin house with house sparrows in the area, they'll harass them just mercilessly. And again, if they can't have access to the nest box, you can minimize the damage they can do. There's also possibly some potential for smart traps. A lot of folks who are really serious into recovering native songbird species actively trap and euthanize house sparrows because they recognize that they are one of the single biggest threats to a breeding population in an area. And the biggest concern with trapping invasive species is you can't risk at all injuring or killing native bird species because the fines are just horrendous if you did so. So that you have to be incredibly careful if you're trapping. But potentially you could also use this to identify a species and automatically release it or notify you, say on your phone or something, and say, hey, I caught a bird. What do you want to do with it? This is what it looks like. And because right now the only real ethical solution is if you put out a trap, you have to actively monitor, which means watch it. Because it's not considered ethical to trap native species. And if you injure or kill them, you're liable for tremendous fines with that. So it could have potential for other areas as well. All right, you ready for the demo? All right, now we haven't been together for like live demos in a long time, so be understanding. So Sadiq, you want to run with a little bit?
Okay, it's the inaugural demo.
Just lets out.
It's the inaugural demo.
you probably should, I don't know, after this, you should come in and work with. Right now I have a camera over there, but you can take a picture and come in because we have three things. We have the thermal, the motion detector, and then the camera over there. You guys are five before. If you come in front of it, if you come in front of this sensor, it will send a signal to the Raspberry Pi, says Raspberry Pi, okay, so open up the door, so it's like wood, and it will open up. So right now it's active, so if I came in front of it,
It's gonna do bird impression.
You may think it's a
That
stupid
PIR sensor might take time to initialize. So oftentimes they calibrate against the background.
So yeah, congratulations. So that too. Right now I have an external battery hooked up to the Raspberry this Sadiq. So I have to make sure that it's on all the time whenever I try to demonstrate. I need to forget. So when I try to turn it on, I'm like, what's going on with it? Why is it working? So I have to first turn it on, and then so if I come in front of it, opens up, and then it closes. Right now, the only whenever it senses something in front of it, it opens and then it closes. But for the in the future, we have to like sense something, take a picture. Right now we can. So take a picture, send it to the Raspberry Pi. What's the picture? Is it something that you want or not? So if it's something that we really want or like, we can just open up this. For now, it's pretty good.
And you and David worked on training a model, right?
Yeah. So teachable machine. So for the AI, so right now it's for the machine learning model, and how we are training it is. So I was working on it. Hopefully the Peter will actually demonstrate what I did. And what I did is I used a website called Teachable Machine. And Teachable Machine is a pretty basic website. It's a very nice website. For those who actually aren't familiar with AI or anything, and you want a quick, like something quick to play with, you can actually go to get started. So it was built by TensorFlow, which is also something that we're going to be actually using for the final AI model. And you have like options. So you can actually train it to like recognize audio. So you can actually put different sound samples of me, Chris, the game, and go to the door. I can put it over there at the door and set the password. So if you set the password and I don't recognize your like sound wave or whatever, I won't let you in. Right now, all you have to do is actually give a lot of pictures. If something, you don't actually have to have a lot of pictures. You don't have to have it. You can have 100 pictures and actually it will do a very good job. And you can have just 100 pictures. And right now, all you need is a class. So for each subject, you need a class for each. So you need a class for each subject. So the first class is for this. So let's say Chris. You need images for Chris. You put them in class 1. You can give it a name. You can change the name. So you can give it a name that's actually defined. So, for example, if we need Chris, recognize Chris, you can name it Chris, so that we know. So if it prints the output, it will say Chris instead of class 1. So if someone else was to use this model and they had his name well defined, they can know that, okay, so if Chris came in front, it would say, hey, Chris is in front of this camera. So
Would I get food though or not?
No.
He doesn't invasive species.
So you can, it's pretty easy, and it's so
Live trap.
good rate code for this. Good rate code is well-framed code for this, but this is a simplified way of actually quickly coming up with the model that you can play with.
So in short, you can push this model then back to the Raspberry Pi and you can run one
Yes.
on the Pi.
So you can download. So there are two things. So there is there are multiple models, and there's a standard TensorFlow model that you can download to use on your computers or computers. But for the for the Raspberry Pi, you use something called TensorFlow Lite. So TensorFlow Lite is specifically built for small microprocessors, and
I was just pulling up the embedded hardware.
so for the embedded one, actually the one that we are using right now is for like microcontrollers, like Arduino boards. So yeah, if we actually train the AI using that, we can't use Raspberry Pi because it's for something smaller.
Gotcha. So we're really over.
I actually use this to train train the machine learning model that recognizes numbers in the Sudoku. What I did is extract all the numbers in the Sudoku and feed them in. And actually, it did a very good job. And I only had, for each number, I had like 200 images for each. But if I was actually training my own machine learning model from scratch without actually using this kind of setup, I would need a lot of images because this behind the scenes you are actually retraining a machine learning model that was already trained. So meaning you're training something that has been trained already. So meaning it makes it simpler. It also reduces time. You can actually train something in less than a minute. So which is good. So which is really good. If you're training it from scratch, you will take. I can't really say how long, but it probably will take a while.
So
Yeah,
Jim ate up most of your time. So
You didn't even start the timer, Ed.
I was being nice.
You're being very nice.
So does anybody have any questions for Sadiq or Jim about any of this stuff?
So why the motion sensor? Couldn't you just run the camera
Yes.
continuously?
So right now we're playing around with the motion sensor, but I like the I don't really like it because there's a little bit of delay. So we're just having this just to play around with it. We're going to be messing around with both a bunch of sensors to see which one is stronger.
Does the servo scare the birds?
So we're also playing around with that.
That's an unknown.
Actually, I think you can actually hear it if you see it over there. It depends on.
When I was a kid, the squirrels used to jump on a squirrel-proof feeder that we had, and the birds would all sit on the thing, knowing that once the feeder popped back up again, they would be able to get food again. So I think if this is a convenient source of food and there's not like a bunch of readily accessible, like Jim's neighbors who have tons of food, I have a feeling the birds would figure it out pretty quick. But I think in town it'll be harder to test because they have so much availability. But
I was just gonna ask, is it like sees a species that it likes and just open the food forever, or is it like a dosing thing? Because like I know our bird feeder, like there's always shit all over the ground because there's been overeat.
Right now we're still like in the program, but what I think the final product would be that be close, see something, is it a bird that we like, open up, and if it leaves, wait for a second, or like wait for some few minutes and then close.
So it doesn't feed the ugly bird.
So it doesn't feed the invasive bird.
It also doses, if you can see in the bottle you passed around, it actually has a stirrer, so it actually, as it's closing, it's mixing the stuff around and dosing through a pretty simple mechanism, a quantity of food.
Okay.
So if the bird sits at it long enough, it depends also on the food, right? Whether it flows well, but there will be a limited amount of food in the window that they're seeing.
Okay.
And there's a fair number of bird feeders that do that already, right? When they land on a thing, it'll click and dispense as a fixed amount. And they're all trying to make that effort, which is to have less litter on the ground, which is a huge problem, because that's how you get squirrels and rats attracted to your bird.
Sean?
Two questions. I mean, one, could you do an inverse squirrel adapter? You know, they make those cones that put in behind a tree where they'll catch the seed that's growing. Like how did the house birds on the ground, the seed on the ground?
Yes, if you have a lot of litter, whatever birds, and they will, it's like, hey, it's food here as well. So ideally you'd have a bird feeder that doesn't create a lot of litter. And that was part of the design as well, is to not just shed a bunch of food. Now practically it also gets to what kind of food you buy. Because if you buy a bag of seed that is mostly seed that birds don't like, they're very quick at just picking it and throwing it out to get to the food that they want. So part of it is also problem creating.
So the second part of this, like, is either going to be an issue with the hostage situations where you have, you know, bluebird during the bird feeder activating the door, house girls in case the bluebird on the wings.
It'll be interesting, and I don't know the answer to that. What I suspect from watching my neighbor's feeder is they're nowhere to be seen if the feeders are empty. In other words, they're not dumb. They're foraging, and they have, I'm guessing, X number of boxes in the neighborhood that they visit. It's not like they fly in and go, oh, it's empty still, right? They quickly learn.
There's
when
also
that box is empty. You just don't see them. So I think the goal would be behavior modification too, which is if they never get fed at a feeder, which will be over the priority, I think, and the reason to stay closed and only default into the closed state is you never want to reward them. If you don't reward them from the beginning, you shouldn't develop a behavior of, hey, I get food here. And ideally, since they have to actively search for food every day, a lot of food, they shouldn't be frequenting. Now, it would be interesting to see, are they smart enough? I might worry about, I mean, there's
an alternative model of this feeder that they started with. Are you gonna tell them, or you want me to tell them? The active version.
Yeah, I mean, you got a choice to how to approach things, and we've sort of settled on one that seems like it would have the least
Negative repercussions.
Because the concern is you want, the starting point would be right, the positions model, which is first do no harm. So and that starts with little things like do you sit open and then only close, right? When you see a house sparrow, then you say, well, did you trap a bird, right? Well, the fix for that is they're pretty quick and you have a slow acting servo, but it's a reasonable thing, right? You don't want people to put these out and then come out and find a dead bird with a head trapped in a bird feeder, right? So that's one concern clearly.
What's the do harm version?
Now, on the other end of the spectrum, there are folks who would actively and enthusiastically embrace a more active means of intelligently euthanizing house sparrows. They just would. I mean, anybody who's been in the community for very long knows that they are one of the significant sources of predation of songbirds. So they actively trap and euthanize them. So one possibility is if you say, if I recognize a house sparrow, I could actively trap you, and then the next logical extension is you could euthanize as well. So one thing you could look at is, are there ways if you had high confidence and you sent somebody a picture of the bird that it captured, could you just say, swipe left to let it go and swipe right to
Send it off.
Send it off to
Exactly.
bird. But the reality is that is an existing thing. I mean, there's people that trap hundreds of them every year simply to reduce the population to help the songbird species. So it's a done thing, and it's done a lot. And and the community is not uniform on that, right? There's some people that say that's horrible. You shouldn't kill little birds. There's people who genuinely have a hard time euthanizing tiny little birds, but they recognize that if they don't do that, they will kill a large number of other bird species, and sort of choosing the lesser two evils. The other one is much more complicated, right? It involves somehow sending them back to Europe where they came from, and that's probably just not going to happen.
Anybody else have any other question? Aaron, of course. Sure. What you got?
You can't shave the
Out in
bird.
the wild. I know Chris has resorted to a fishing net upstairs.
I've got him with a fishing net before.
Is it working?
We caught ducks with your fishing net. No, we got ducks out of the sewer with your fishing net. Aaron gave us a fishing net to catch birds upstairs when the birds come in, because the cat doesn't know what to do.
If you do a little search, there are a number of
Exactly.
there are a handful of really good automatic traps that folks have developed.
So it traps the
for
birds, hangs onto them, and then a human has to come and figure it out. So.
And the downside of them is, of course, you still have to actively monitor them, because if you trap a native species in there and it is injured or killed, you're liable for thousands of dollars in fines, right? It's a federal offense to kill native songbird species. So again, you can set up this trap that get very effective, and people catch hundreds of birds with them, but you have to actively monitor and make sure you're not bycatching a native species. Now, the advantage of, if you could add some intelligence to that, is you could put them in a holding area when they're caught initially, and you could say, send the person on their phone a picture that says, do you want to keep this bird caught, or do you want to release it? Now, if you had a trap like that, now somebody would just have to keep their phone with them, and they could then remotely, potentially, monitor a trap that was set up and do so in a way that's far more humane, considered more humane.
All right, I'm walking you off.
All right. Thanks, everyone.
So
That's the one where I was, I'll be leaving you.
yeah, after the meeting, you guys can, anybody can check it out. Scott and the boys, you guys want to go? We'll go from computers to like, I don't know, what would this would be considered hard, like prison labor activities?
What's that there?
This is like prison labor. We're going from computer activities to prison labor
Yeah.
activities.
Caveman.
Yeah, caveman. There you go.
So, my name's Scott, I'm the long-term member here, the my son is Luke, and we're gonna demonstrate, whether rock is feathers and wedges. So, I'm gonna take this around, this is the technology that we're using to, basically generate leverage on the rock to be able to split it apart. So, we pre-drilled series of holes in the rock using a hammer drill. These particular feather and wedge sets, each one basically has a hole diameter that works well. You need to be able to put pressure on the rock, but not bottom out. The way this works is as you drive the wedge in, it forces the feathers out. Yeah, so you're trying to put a uniform pressure across edges. So, you guys want to get them set up in the bag or where did that might be a little greasy, but
We don't have those speaker box.
Just fake one.
Those the hiding power ones. Is there a key under?
yeah. Okay, so that's it. So this is how deep we drilled the hole, the 4 holes in this. And we have probably over drilled the number of holes for this rock. We could probably got away with every 6 inches, but we've done every 4 because demonstration.
Oh, it's pre-drilled.
Yeah, you can find them in the wild like this with the holes already.
That's preferred rock.
If you can find them pre-drilled,
It's a
that
domesticated rock.
That's a real rock.
it's probably about 250 pounds. These slow them down.
How long did it take to drill those holes?
About 20 minutes total. I did find the first one we did one outside. There's a whole, well, why? I guess it's yeah, it's a cross project. And it's a good question. So I've always had you might know me as kind of a metal worker or a machine control something, but I've always had a hobby interest in stoneworking. There's a lot of cool analogies like metalworking, the metalworking class for kids I teach is like a hacksaw on a file. You use tools to affect the material that you don't necessarily think is like that effectively. And stone is certainly like that as well. I've had sort of a very amateur hobby most of my life. So also I think it's good to just have kind of a sense for materials. And so we didn't really have a great way for splitting granite hole that we found. Other than just have a pile on back. Smaller might be better, I guess, maybe. But I wanted to do it. I wanted to give the boys a sense of like, what does it feel like to split a hole? Because that doesn't seem like an intuitive kind of operation. So we're going to do that today here. We've got the feathers down in the hole. Wedges ready to go. They're all, so the wedges are all aligned to push this way on the boulder. We've got 4 holes at 4 inches on. If you want to come up and take a look, go ahead. Safety glasses and the glasses are
I'm surprised they didn't put a plant in the audience for somebody to check. Oh, it's really heavy. Yeah. See the fiberglass on it cracks.
I've seen people do this on the internet where they're doing this on a huge scale.
Yeah, you can split
Not
very
using
large
machines,
rocks.
they're- yeah.
Just keep, and you'll see how much force we end up getting on the wedges. It's not really a lot of force. As long as you go down and work your way. And we'll go pretty quick here. You can go a little slower. If you want to get a straighter, flatter split, there's some things you can do. You can prep. You know, we could actually start in with a chisel like this or like a carbide chisel to start fractures all the way around. We get a more square face. If you go slower, it tends to be more square. But we'll just go for it here and see how it works. You can sometimes hear the cleavage happen in the stone as you go. But yeah, so keep that.
Should we be singing a song?
Henry.
The people have done this for like 100 years ago when they're building railroads.
Oh, yes.
You guys have been working on your rock welding as well, right? Just to rejoin it.
Yeah.
Rocks are available for sale if anybody's interested.
Cash and carry though.
I'm actually seriously selling the rocks. If anybody wants to buy a pile of rocks, I got a lot of them.
NFT.
So could you take now like a, I don't know, 2-inch slice of it off?
If you want to generally do it in half, roughly. If you try to take, you can imagine it would just, if you try to do too little, it could move on. It would be worth experimenting with to see if we wanted to make steps or add a stone or something. If you really wanted slabs, you can definitely, like, you could split. I imagine you could split this again if it was about half. But if you try to take just off one side, then it doesn't work.
There's rock that have natural cleaving planes like that. Like slate.
Yeah, right. This doesn't really. Granite is good to split actually this way because it's so tough that you get a split on. Whereas if it's a softer stone, the wedges won't necessarily affect the pressure across the whole face of it, and it'll just localize. So it actually is good that it's hard rock.
Does it go straight because it's a pretty uniform density? Does it like have any grain to it?
This doesn't really have any particular grain I'm aware of. I mean, actually, there may be a grain, but we didn't pay any attention to what it was.
Is this something they would have used like 4,000 years ago to meet the pyramids or like stone?
Well, so they would in rock quarries they would use this. They would chisel drill holes, and then they would drive wooden dowels, and pour water. And the expansion of the water would affect a similar wedge. Yeah, I don't know if they could manufacture because the wedge part is really hard. It's really hard. Yeah, and then the water expansion. So that's
How long does that take to split though? I mean, you could literally invent a hammer in time to split.
You guys got, never mind.
What's that?
Put ice, poured water in, and have it get.
I don't know. I would imagine it would. It's quite a lot of power there, but I haven't heard of it. If it's possible, I'm sure people are doing it.
Bob's like,
Are you limited to flat surfaces, or can you do like a wedge of cheese?
Well, it's pretty much going to be a planar sleeve the way that this works, but you could do, so we could do this. Split this one and get a wedge. You could end up with a wedge of rock, but not in one split. You'd have to.
Mark?
I'm curious what would happen with concrete because of the, well, just because that's, I mean, this is all the same grain, right? So I'm wondering, because I haven't seen it done with concrete, but.
If only we had a lot of concrete to like
Yes.
split. Yeah. If only there was an opportunity.
I mean,
You're standing on it.
You blocked yourself.
Have you done it in a giant here, cut all the passes? I'm just curious, if you ever looked, or your sons have ever looked at how you do videos of how you clean diamonds?
well, gemstones are, to get the facets, it's an abrasive process. and there's a special jig to get the
Oh,
angle right
And
down to the braid.
initially it's cleaved, and then after that it's all ground. Yeah.
Yeah, like cleaving part's kind of, when they've done like the really big ones, it's like, oh, shoot,
Oops.
where's the right, because if you mess up, yeah.
It's two small spots, two small rocks instead of one big one that you
Well,
want
it's
to
like
keep.
you're trying to find, okay, this is the cleavage here, and then you do it, it's just kind of tapping and praying, cut it right.
Yeah, so we've been having fun with it. The biggest learning lesson for me was around the hammer drilling, which was we were putting way too much pressure at our initial hammer drill, so you'll see the heat distortion on the tip of one of those. They do get hot, but if they get hot, you're pressing too hard. You really want to just have the hammer drill gliding a little bit, maybe a little bit of pressure once the product is close to its own weight, actually hammering versus if you're pressing down, it's not doing the hammer.
What machine did you use?
We use the.
It's a quality Harbor Freight product. It's like the cheapest hammer drill.
So
you can
it
buy.
lasted through 4 holes?
Oh.
Yeah.
It's this one.
So you'll see the chuck style on those. It's not something you just put in.
It's like a pin and sleeve almost.
Yeah. So it's a positive hammer effect rather than a hammer drill you have for a home drill for drilling into like a quarter inch bit if it was a wall or something. You just chuck it like a regular drill. But for a serious hammer drill, it's a separate drill style. That's kind of a chuck style. But it's well worth it.
No cooling liquid necessary?
No, we didn't, and it's typical not. So yeah, the first one we did, I think we drilled for probably 2 hours to get 5 or 6 holes, 4 or 5 holes. Yeah, they were for little. So this was like lessons.
It's fascinating.
Yeah.
Have you tried a hammer or a traditional spin?
Oh, sure. Yeah, I have one. I have a chisel for doing that, right? Like, so traditionally, yeah, you would just use a pointed chisel, like across. It looks a lot like that cross dip, but you hammer, and get your holes, and then before hammer drill. Oh no,
But at 2 hours a hole, I might be worth racing.
it was 2 hours for all 5.
Oh.
Oh, that would have been fast to do that.
No, I drilled pretty quick. Scott wasn't here for 20-some minutes for the.
Yeah,
Right, for these
20
ones.
is probably a high estimate, and that was getting the stuff, all the stuff out there.
And you said they were twice as deep as they had to be.
No, well, these probably are deeper than they need to be, but if you bottom this out, you're in trouble, basically. You need to then drill another hole beside it, and so these wedges actually are, I think they're metric. They're sold as 5/8, and it's between the 9/16 and a 5/8. And so the next one we do, but we might try the 9/16 just because you take the radius out of 16, it's probably less stone removal will go a lot faster and all that. And then, but we were at about the depth for safety purposes that we did. And I don't know if you saw that when Lucas hammered, which there was some variance in terms of how deep. It was different enough where you just get a hole that we need to get it all the way down. It's our second one, so we haven't had that yet.
You've learned a
So,
lot. Short amount of time.
do the feathers apply uniform pressure the whole length of the?
They
Are they basically square wall?
yeah, I believe they're designed to do that.
Okay.
Square.
Yeah. It's not a totally uniform paper, but I think that the angles generally speaking match, so that it is.
So it's stated, yes, it presses.
All right.
All right.
Thank you, guys. All right, I've got an easy one. Let's see here. So, somebody had emailed and asked if we had a forge, which I brought up here so you guys can see it. And somebody donated one about, I don't know, 4 or so years ago. And it's kind of been hanging out upstairs because we didn't really have a good spot to set it up and do anything with it. And so I said, sure, we have a forge. And I figured I'd go up and like, really all I thought it needed was a belt to go around because it didn't have the belt was kind of all frayed and gobbled up and stuck in the blower drive. So I pulled out the, maybe let's get the car windows down. I should go. Close up your windows, just ran it up. So I pulled the belt and sewed it so that it would loop all solid, and then tried it. And the way this thing works is there is this big loopy guy here, and it gets pulled up and down, and then it runs the belt. And the belt used to run to a very old school blower, which is right by Jim's foot there. Jim, trying to grab that box or thing out of the box and hold it up. It's only slightly heavy. It's pretty clean otherwise. So it's a really old school cast Babbitt bearing 2-blade impeller blower guy. And this thing's supposed to spin it, and then you pump it a bunch of times. So there's a handle that goes on here that pulls this thing up and down. And the problem was it's really noisy, which is really annoying, at least for our neighbors it's going to be, because you got to use this thing outside. So I decided the first step was trying to make it quiet. So I pulled out the little crawls that are in here. They're steel on steel, and they're really noisy. And so I decided, well, I'll put plastic ones in, because plastic will make it a lot quieter. So these are actually HDPE, and they're still really annoying.
That's quiet.
So I decided no matter what I did with this thing, there was no chance that we're going to be able to keep it 1910 intact. So I pulled the parts off so we could restore it if we want to, but I decided we need to go over to a modern system because it's not going to work long-term, making a ton of noise outside. And so the very first thing I did, and this presentation is kind of around how to get things to fit on a really old thing that you don't have like designs or drawings or anything for. So the very first step is I grabbed a crayon, and I forget who was giving me crap, because I had this fancy sheet of paper here going, and I just used the crayon to get a rubbing of this part up here and where this plate fit on, so that I could get the template for what that blower mounted to. Knowing that this is a casting that was made somewhere between 1890 and 1910, there's no way it's going to be uniform, and in fact, it's not really. So I drew a couple of reference lines in there, and then I put it in CAD. And the key thing is trying to dimension and constrain this thing correctly based on what I can infer from these measurements, because you don't have unlimited measurements. I can't measure everything. I don't have a CMM. And so I kind of winged it and then printed this off and verified it, and it fit up where I would expect before I went over to a steel one. The second issue then was I went upstairs and dug around and found this old furnace inducer motor. So this is what makes a draft in your propane or your natural gas or propane powered furnace. And I gave it to Todd, actually, who was here, and Todd was wandering around his board, and I said, well, here, if you want to draw this thing up for me, I just need a template for the bolt pattern. So he sat with a caliper and measured it and said, every single bolt is unique, and I got to go. And left it at that. So I threw it on the flatbed scanner and scanned it in, and then brought in the 600 DPI image into CorelDRAW and laid over, it's hard to see up here, but there's a red circle around everything, all the features that I needed. And then I pulled off the rest of the parts off the forge to make some space. These were the original, ratcheting mechanism. Like I said, I swapped that out right away, and then it was too loud, so moved on with that and pulled the rest of the pieces off. I went to the plasma cutter of that first drawing that I showed, and so I used a CNC plasma cutter and a piece of scrap steel we had laying around, about 1/4 inch thick, to make sure that it's right up where the fire is. So I wanted something that wouldn't deform. And then had the plasma cutter cut that out, which takes about 20 or 30 seconds, which was very nice. And then the other fun trivia that I didn't realize, that blower, when you looked at it, there's like one duct kind of goes to a little turning housing, and the other part goes to the blower. I didn't realize that one of the important parts of this is you need an ash clean out, because as it's running, the ash accumulates. And so the ash then settles down and it ends up blocking up your draft. And so generally they have a tube to drop ash out. So I replicated that on the bottom here. It turns out with modern technology, you probably don't need an ash clean out anymore, but we'll get back to that in a few minutes. And then the other thing is I wanted to join my blower and do it fancy and proper at a nice angle coming into this upright tube. And of course, we need to involve all of the possible complexity around tools. And so this is going to go on the CNC machine with a 4th axis to cut out my intersection of my 2 tubes. So I threw that on the Tormach mill on the 4th axis and found, luckily, 2 chunks of conduit that were right about the right size of what we needed. and test ran it, and then went all the way through to lap out my intersection. And then I had to do the same thing with my end of my tube to cope that to fit. The issue is, it turns out Fusion 360 cannot go all the way around something. It throws a cyclic, cannot generate a cyclic toolpath, even though I've done this before. So I pulled up my old program, and sure enough, it generated the code successfully. So I don't know what the hell they changed, but they broke their toolpath generator. And anyway, the trick is, if anybody ever needs to do it, you have to put a wall in the middle of your part so that it cuts almost all the way around and it stops just short, and then it works fine. So I left the wall like 0.02 of an inch vertical just to interrupt the toolpath, and then it's okay. So I did that, and then I chopped it out, and I looked at it, it kind of looked funny. And I was like, I don't know. And I walked back to the welding shop, and I was like, what the hell is going on? This is not what I wanted. This is not CNC precision. This is the opposite of CNC precision. This is quite a big hole to gap, and I'm a pretty good welder, but not that good a welder. So then I realized that the little piece of scrap that was sitting in the CNC was actually the piece that I wanted. And this was the scrap piece. So I cut the wrong end. So my cut was mirrored. So I needed to cut the opposite side. So since I'm a decent enough welder, I decided, you know what, this looks perfect. We're going to go ahead and weld that on, and then we're going to go ahead and weld the tube on. And then it looks great. It's exactly what I was after. So it's precisely CNC'd with a little extension. So I did what I could. It's a forge. It's, you know, it's supposed to look rustic. So maybe in the next one, I'll make sure to mirror it. So I left the tube long, as I was intending to do with the other tube, but that didn't work out. And so I brought it back in the shop and chopped it off to make it about the right height. I used a hole punch and punched holes through my piece of paper and held that on to the blower, inducer blower, to make sure that the holes actually matched up. Because this was going to be a big piece of metal, and so I don't want to waste a big chunk. And then I also verified that my pipes will fit, my blower has clearance, and that door can open with the blower and all that kind of stuff, so that I wouldn't do anything else stupid. Threw this on the plasma cutter and chopped out this other piece. This was that top piece cleaned up. Got everything assembled and kind of lightly fit. Jammed it on there to try and figure out whether it would fit or not, and realized it's hard to see, but there's a ring on the bottom. And of course, where this plate lines up, it lines up perfectly with where the ring is. And so it's in the way. So I needed to take that off. So it looked like I was gonna have to go all the way and take it all apart, but we're too lazy for that. So we have an iron worker back there. And so I just threw it on the iron worker and chomped off the corner. And then I brought it back over to the forge and realized that I just chomped off this corner, not this corner. And so then I went ahead and chopped off the other corner too. It kind of gives it this artsy look, so it was good. What do they say? Cut twice, measure. I think measure once. That's right. So anyway, I closed up the bottom. We have a genuine champion, by the way. It's hard to see up here, but this is apparently one of 3 forge manufacturers back in the day. Or somebody threw genuine champion in their casting and did the same. So I closed this thing up, kicked on my impeller and my inducer blower, and had like a rocket ship. And so in the picture, I have the inducer, this ash clean out totally open, so we're not getting as much airflow. And I threw a chunk of paper over top of the inlet, which was the plan anyways, is to put an inlet door on it to control the airflow. And it, just with plain wood out of the wood shop, runs really well. This is a little chunk of steel that got up red hot without really trying to do anything. Normally you can't run wood because it doesn't get hot enough. You generally need coal or better yet, coke, which is a reduced form of coal. It burns even hotter. And I think with coal, the fire will be a little less messy. But it was definitely roaring away. So works pretty good. Exactly. You can cook burgers really fast on it. I can tell you that much. You throw your burger on there and the outside's done in a few seconds. So anyway, let's see here. Come on. Maybe that's my last slide. I'll leave you with the campfire. Does anybody got any questions?
A lot of mistakes in that process. Your educational credentials again?
That was, well, you know, I'm going to do it again.
Masters in what?
nothing important. Mechanical engineering is not forge work. That's well beyond beforehand. Yes.
Wasn't there anyone around who could walk by and tell you all the things you were doing wrong?
I wish there was. Nobody was. Jim and Sadiq were totally engrossed in their project yesterday, trying to string things together. So, and nobody else was really on as quiet. So it's good. It was a good holiday day to pick to work on things. Nobody's around to bug me. Yes.
So, I mean, I feel like this is cool, but like.
No, it's hot, Sean. It's hot. Thank you.
Well, this was a really cool mechanism that you decided not to make. Curious with the idea that you're not reversing to this loud. So what do you do with the forge that's not like banging steel on it?
It turns out if you know how to forge things and you heat the metal properly, it's actually quite quiet. As long as your anvil is coupled to something big and heavy, like a giant stump in the back, it's actually pretty, it shouldn't be loud. No, it shouldn't ring. If your anvil rings, it's either not coupled to something or your metal is not hot. So it should be like a thud, like a dead thud. If you ring, like they do on the TV shows and the movies, your stuff is not working the way it's supposed to. You need either more mass to couple to, or your metal is not getting hot enough. And I mean, as your metal cools and as you're working it, you don't need to have it red hot, but then you're generally not striking as hard because you're trying to form it, not smash it. So it's into what you're doing. But you are big enough, you're not going to heat it at all. You'll just be able to rail on it, so you don't have to worry about it. Yeah.
I guess how hot does it get, and or is there something in particular you're trying to work?
I made this for somebody else. It's just a theme around here. Scott and I both like to build tools for other people, so I don't know. And it seems to get hot enough to heat things up well enough. It has motivated me to work on our 5,000 watt induction furnace. We have a forge that runs on electricity, which can live indoors and heat up instantly and cool down instantly. So yesterday I went to bring this back inside after I ran a little test fire. And after like an hour and a half, it was still ungodly hot. So I hosed the whole thing down with a hose. So one of the other features is really easy to take the inducer blower motor off, and you can hose the whole thing down because it doesn't care. But the cast iron, it's about 70 pounds, and it turns out when you heat 70 pounds up hot, it stays hot for a really long time. So I don't know, that's my other thing. It's like, we want to build it into, we should probably put a back chimney on it and a little roof above it because it'll help control the heat and where it's going. But we'll see. The original thing on there had like a shield this way to shield the person who's pumping. So typically this would be a 2-person run, 1 person would be pumping and 1 person would be working. But in 1910, that was easy. You paid the kid around the street who was like 6 years old who can barely do anything, and then you're good. But now there's like child labor laws and stuff, so we got to kind of use like electricity where we can.
Scott gets around it.
Yeah. Luke's young enough. Maybe he'd wanna pump the forge all day. Maybe.
He's breaking
The pay's good.
I assume as long as you keep the inducer running, it's not going to melt that crystal.
Yeah, so that's the other thing is we're just gonna block the furnace inducer motor inlet. And let's be honest, there's probably a reason the inducer furnace was upstairs, so who knows how much life's left in that thing. But it is all plastic. It'll go down in a haze of glory when it does go. Any other questions from anybody? Any other presentation things? That's why I waited like an hour and a half. Yeah, I mean it's cast is pretty ductile and durable, but yeah, I wouldn't spray it down while it's like.
So during that cool down time, it sounds like it's a pretty devious bird bath.
Oh, Aaron, come on now. I was gonna let Jim put that together.
Mix the Kevin.
Pretty cooked. I think the induction heater would work better.
I think the induction heater in the long run will work better. It is cool. Like I said, I built it to make it so we can reverse all of it and put it back together again the way it was. So the Babbitt bearing loud ratchety thing is pretty cool, but it just seemed like not quite what we're after. Any other things anybody wanted to share? Otherwise, we can go around. You can say who you are or what you're into or whatever else. And go from there. All right, Sean, take it away. Who are you?
I'm Sean. Work for a modeling company. I'm here to currently working on a farm scale. Tim, I originally I teach at the school for the blind, a little math, and some of the things with assistive technology and woodworking is my scroll saw.
I can go. Chris, I'm a software developer, and I think mostly what I've been working on lately is different ham radio projects, so building antennas and things like that.
My name is Joe. I'm pretty new to town. Just moved here like a week or 2 ago. But I did go to school here. I did Formula SAE. Right now, I'm pretty new to like the making scene. I just got an Ender 3 and I'm just upgrading it kind of right now, and I'm making planners for my wife, and that's about it. So sticking pretty simple, but in the future, I'd like to just like 3D print an RC car. I also want to try. I also made an espresso machine. But that was just like a bunch of parts off the shelf and just slapped them together. So that was a pretty, yeah. So, yeah. So if you guys want to teach anybody anything, yeah. It was a little hard to bring on my bike, but maybe I shouldn't throw.
Yeah, I was gonna say.
Yeah, I'll bring it in next time. It doesn't work right now. Classic.
My name's Nathaniel. I'm a solder technician with a company called Proactive Engineering. I do PCB design and manufacturing. I'm just generally computer tech geek, hacker, that sort of thing. I spent time in the Appleton Makerspace before I moved down to Madison about a year ago. So now it's like, oh, I was looking for a Makerspace, and finally one of them was open. Well, excuse me, one was open in person. So I was getting kind of tired of video calls everywhere. So.
I'm Chris, you already know me. Sadiq?
My name is Sadiq, and I like programming software and all that. Yeah.
Sadiq's looking for a sweet internship for next summer. So if anybody's got any ideas on some cool places to go intern, that's what he's after.
Hi, I'm Bob. I do consumer electronics and IoT stuff. I'm Matt. I code for a living, but here at Sector, I mostly am in the workshop.
It's not bad. Got, metalworking and miniatures.
Where are you going next year?
I'm me, he's him. I'm Aaron. Everybody knows me. No? I do all the cool shit around here.
Radiator repairman is what Adam's gonna be. Shortly. Truck's front leak.
I'm Mark. I sweep the floor sometimes and looking forward to construction starting up again. I've been replaced by three devices, so I'm looking forward to construction starting up again.
I'm John. I've retired engineer at companies. That was, now I'm no longer, I'm a has-been. But got a woodworking shop in my backyard that I keep playing with. And in retirement, I kind of graduated to, I've been making some model boats. And I'm having some fun with that. So laser cutting, 3D printing, but I'm using shape weights for 3D printing. That's just a few things here and there. That's good.
I probably hold the record for the longest time it took someone to finish a task.
The pandemic takes it. You gotta take out the pandemic time.
Yeah, I started right before the pandemic, and then the pandemic came back 30 years ago. So decided to finally do a project other than my desk.
I still haven't finished Iron Man.
All right. Well, thank you for coming. The internet people, we're not going to try to do intros because I have nothing to get you guys on a speaker loud enough that everyone can hear. So, hello, internet people. Thank you for coming. I guess you can type. That's true. Here you go. I'll maximize your typing window. You guys can harass everyone. So if anyone wants to see what's here, I can do a tour, and plus I'll burn some time here. It's supposed to stop raining shortly-ish, hopefully. Maybe. I figured for all the bikers, enjoy that. So we'll take a slow tour. So yeah, if you guys want to meet by the toolbox, like we can wander around. Anybody else who wants to is welcome to hang around. You can check out Sadiq's crazy Raspberry Pi system here. Otherwise, I think Brian's got the arcade running if you're looking to burn time and not get wet. So thanks.